Hello, welcome to the video. In this lesson, we're going to be looking at section 9.3, where we're going to be looking at trigonometric functions of any angle. So here it says, how can you use the unit circle to define trigonometric functions of any angle? So looking at the unit circle is sort of the introduction to trigonometry, and uh, it is the basis off of being able to find any angle within the unit circle. And we'll talk about the unit circle and talking about finding those general definitions. So first off, let's look at the general definitions of a trig function. So if you had a circle, maybe not specifically the unit circle, inside a coordinate plane. If you recall, the equation for a circle where its center point is the origin is x squared plus y squared equals r squared, where r is the radius and x and y are any point that is on that particular circle. So we can discover what the trig function is as long as we know at least two of the three terms. So if we know x and y, we can find r. If we know r and we know x, we can find y. And we can do all that by using essentially the Pythagorean theorem. And then to discover what the six trig functions are, it's simply those values in the ratio. So sine is y over r. Cosine is x over r. Tangent is y over x, and then cosecant, secant, and cotangent are just the reciprocals of sine, cosine, tangent, respectively. So how do we go about finding these? So in this particular one, they're giving us a point at negative 4 comma 3. They want to know um, this angle theta in standard position. They want us to evaluate the six trig functions of this. So essentially what we got here, this distance here, because it's, in coordinate plane talk, we're going to say that this is a negative 4, and this is a positive 3. But in reality, it's a distance of 4 and a distance of 3 for those two sides. So we can use the Pythagorean theorem to find r. So r is going to be 3 squared, which is 9, plus negative 4 squared, which is 16, which equals 25. Square root of 25 is 5. So r is 5. So I have all three of my values in order to find the six. So I got sine of theta, cosine of theta, tangent of theta. Cosine, sine, cosine, tangent. So sine is y over r. So this one's going to be 3 over 5. Cosine is going to be, what, negative 4 over 5, and tangent is going to be 3 over negative 4. So cosecant of theta, secant of theta, and cotangent of theta are just going to be the reciprocals of their respective sine, cosine, tangent. So this is going to be 5 over 3. This is going to be 5 over negative 4. And this is going to be negative 4 over 3. And those are the six trig functions for that angle in standard position. When we are dealing with the unit circle, we're dealing with still a circle, but the unit circle means that r is always going to be 1. R will always be 1 in this particular instance. And that'll help us be able to determine values for x and y depending on um, what angle they tend to give us. So for instance, here they want us to use the unit circle to evaluate the six trig functions of 270 degrees. So if you looked at this in a coordinate plane to try to find 270 degrees, it is right here because this is 90, this is 180, this is 270. Well, in a coordinate sense, the location of this is 0, comma, -1. This is x and this is y. I know that r is 1. So I have all three of my values. I have enough information to find my sine. Actually, it's going to be sine of 270, cosine of 270, and tangent of 270. It is going to be equal to, this one is going to be y over r, so that's -1, because -1 divided by 1 is still -1. This one here is going to be 0 divided by 1, that's 0. This one here is going to be um, opposite over, so it's be -1 over 0. Can't divide that, so this is undefined. Looking at the reciprocal ones, cosecant of, whoops, 270, secant of 270, and cotangent of 270. So this one here is still also going to be -1 because it just gets flipped. Because 0 now is going to be on the bottom, this one here is going to be undefined. And this one here, when you flip it, is just going to be 0. Questions 1 through 3 are very similar to that one where we found it at coordinate -4, 3. Uh, if you want them done, please leave a comment. What I will do is I will do number 4. So number 4 here is the unit circle with 180. So looking here, 180 is right here. The location of that coordinate is going to be -1, comma 0. So sine of 180, cosine of 180, tangent of 180. So we got 0 divided by 1, that's 0. Cosine of 180 is -1 divided, so that's -1. Tangent of 180 is uh, y divided by x, so that's 0. So cosecant of 180, secant of 180, and then cotangent of 180. If I were to put this on a reciprocal, this would be undefined. If I flip this, this would still be -1. And if I flip that, that'd make it 0, so this would also be undefined. Last a couple concepts to look at. They want us to look at what is called a reference angle with respect to uh, any angle in standard position. So if you look at these different reference angles, they're all angles that are with respect to the x-axis, okay? They're always going to be acute and they're always going to be positive, okay? So depending on uh, which coordinate you're in, your reference angles. So if you look here, if your standard angle is in quadrant 2, your reference angle is going to be located here somewhere. If your standard angle is in quadrant 3, your reference angle is going to be here. And if you're in quadrant 4, your reference angle is going to be here. So essentially what you're going to do is if you have it in degrees for quadrant 2, it is simply going to be 180 subtracted by whatever angle that you were given. Here it's going to be whatever angle you're given in quadrant 3 subtracted by 180. And then finally for quadrant 4, it's going to be 360 subtracted by whatever angle you're given. There is no reference angle in quadrant 1 because that's the same as your standard position angle. So they were asking you to find a reference angle for these two angles. One is 5 pi over 3, and the other one is negative 130 degrees. So there's two things that I like to do with these different examples. First off, I like to make all my radians and degrees. It's just easier for me to identify where they're located. I can't, sometimes I have a hard time seeing where 5 pi over 3 is in my coordinate plane. So it's just easier for me to put it into degrees. So if I take 5 times 180 divided by 3, and then I cancel out the pi's, this is going to be 300 degrees. So I can identify where 300 degrees is because it's right about here. All right. So what I'm left with is this reference angle. This reference angle is going to be 360 minus 300, which is 60 degrees. So my reference angle is 60 degrees. But the last thing I got to do is I have to turn it back into radians. So 60 degrees in radians is going to be 60 over 180, which is what, 1/3, which then you attach pi with it. So 60 degree in radians is pi over 3. So my reference angle for 5 pi over 3 is pi over 3. When I look at example B, for instance, I have a negative 130. What I want to do is I want to place that into a positive. Uh, so I go here. So negative 130 is right about here. I want to figure out what that is in a positive degree. So this right here is essentially going to be 360 minus 130, which is what, 230 degrees. So this is 230. So then I take 180 minus 230 minus 180, which I get 50. So right here is 50 degrees. Since it's degrees, I leave it as that. 50 degrees is my reference angle. Why is finding a reference angle useful? Well, it is useful, especially when you are trying to evaluate trig functions. More specifically, being able to evaluate those special trig functions where it's like 30 degrees, 60 degrees, or 45 degrees. Okay. It's nice because we can reference back to the charts from 9.2, and then we can use that chart to help us determine what the result is for those specific trig functions. What we have here in each of these quadrants determines the sign of the trig function. So if you look here in quadrant 1, it doesn't matter which of the 6 trig functions are, all 6 of them are going to be positive. But if you look in quadrant 2, sine and um, secant will be positive, cosine, sine and cosecant are positive, cosine and secant are negative, tangent and cotangent are negative. If you look on quadrant 3, sine and cosecant are negative, uh, cosine and secant are negative, tangent and cotangent are positive, sine and secant are negative, sine and secant, I'm just messing up words. Cosecant negative, sine cosecant negative, cosine secant positive, and tangent cotangent negative. Sorry about that. So what you're going to do is you're going to get these reference angles. Hopefully these reference angles are one of these three, and then you can evaluate them by what they were, and then determining what the sign is first what kind of trig function it is and what quadrant it is. So to finish up, here it asks us to evaluate the tangent of negative 240 degrees. So what I'm going to do first is I'm going to figure out where 240 degrees is located. So negative 240 is somewhere, I'm going to say right about here, which means that my reference angle is right here. So to find that, I'm just going to take 360 minus 240, which means that this angle right here is 120, and what's left over is 60. So my reference angle for negative 240 is 60. So I can try to find the tangent of 60 degrees. Well, luckily we have 60 as one of those special angle measures. If I go back to the chart, the tangent of 60 degrees is the square root of 3. All right, but now we have to go back to this chart here, and oh, tangent in quadrant 2 is negative. So that means that the tangent of negative 240 is going to be equal to a negative square root of 3. In part B, cosecant, they say it's 17 pi over 6. Okay, again, I like to put it in degrees. So this is going to be cosecant of 510 degrees. So drawing this out, so I got 360, this is 5, so this is 450, so it's somewhere right about here. So I got to figure out what this is. So if I took 510 subtracted by 360, I get 150. 180 minus 150 is 30. So my reference angle right here is 30. So now I have to find the cosecant of 30 degrees. Well, if I go back to my chart, cosecant of 30 degrees is 2. So now this is also in quadrant 2. I look at it, oh, it's positive. So that means that in this particular instance, cosecant of 17 pi over 6 is just positive 2. And that is using trigonometric functions of any angle. Hope this helps. Till next time.